decrease their quantity, right? So conjectural variations can be seen as a broad framework which puts together all of these different models and just thinks that, well, look, I'm going to choose something, and then I'm going to think about how other people will react to that. Rather than holding fixed what other people do, what they do might change when I change what I do. And the thing that's useful about this is it lets us sort of have a broad framework in which we can talk about all these things and reduce it to a single parameter. Okay. So let's consider the basic Cournot model, and now let's put in conjectures into that, right? So again, the Cournot model was this, right? Price depends on my quantity and the quantities of all the other firms times quantity. Okay, but now we're going to add an extra element, which is that I'm going to think, hey, if I increase my quantity, that will change the quantities produced by all the other firms. If I do that, John, what is my optimal pricing formula going to be? If now, when I increase my quantity, that leads to a change in the other firm's quantities as well as my own. So just take the derivative of my profits with respect to my quantity, now taking into account the fact that I'm going to see the other firm's quantities changing when I change my quantity by this much.
So derivative of the first. So P prime Q plus
Yeah.
P.
Plus what?
P.
That's P minus C, right? But then there's also going to, it's not just going to be P prime times Q, it's going to be P prime. How much does the total quantity change when I change my quantity? It increases by 1, but it also increases by how much other people's quantity increases when my quantity increases, right?
So 1 plus that.
Exactly.
Okay.
Exactly. So it's going to be 1 plus that thing there. So it's going to be P plus P prime times Q, I, times 1 plus D, how much other people's quantity changes when my quantity changes, is equal to C, right? So if other people are going to increase their quantity when I increase my quantity, then that's going to cause marginal revenue to be even lower than price. If other people, when I increase my quantity, respond aggressively to that and increase their quantity, right, then that's going to lead marginal revenue to be below price, further below price. It's going to magnify this. And that's what you'd expect in a cartel, right? If I increase my quantity, other people retaliate by increasing their quantities, right? This is called a conjectured accommodating reaction. Why is it called accommodating? Because if I reduce my quantity and I'm nice, other people are nice back to me, right? By reducing their quantity. Okay. And this is how we facilitate collusion. On the other hand, if when I increase quantity, they reduce quantity, that is, if I decrease quantity, they sort of step into the gap and fill that gap, right? That's called an aggressive reaction. And in fact, in the extreme, if this were equal to -1, this would be exactly the Bertrand model, because if every time I decrease my quantity, other people step in to fill the gap, right? That's exactly their price. The price is going to stay fixed, right? So this was actually on your exam, this exact model, right? I asked you to think about, in the later parts, if I increase my quantity and I expect that will change how much other people are producing, how do I behave? Right? Okay. So we can also stick these conjectures into a model of differentiated products Nash and pricing, but I'm not going to talk about that. Okay, so a natural question is how much Stigler's factors impact the extent to which I think other firms will retaliate if I increase my quantity, right? We know, we identified a bunch of factors that intuitively seem like they would increase the extent to which I'd expect that, but we haven't thought about how much that would happen. And that's really sort of an empirical question. This parameter is in different markets, and then try to relate that to the extent to which prices are transparent, people interact frequently, etc., right? And this will help us to determine the impact that these factors have on the amount of collusion that's going on. In some sense, we can measure the amount of collusion by the value of this parameter in different markets. Right? That's sort of a very natural notion of how much collusion is going on. And so a natural approach is to regress this conjectural variations parameter on a bunch of the factors that we were talking about. We can try to measure those in different industries and run a regression. Amazingly, no one has actually done this as far as I know. No one's actually attempted to undertake this exercise, but it's sort of the most natural thing that one would do to try to figure out how much these different Stigler factors matter. The one reason no one has done this is that we have to measure this conjectural variations parameter in a bunch of different industries, and this is a bit difficult, but there's two approaches people have taken to measuring the conjectural variations parameter. The first is to try to measure the cost and measure the slope of the demand, and then just to solve out for the conjectural variations parameter, right? Another approach, however, this was sort of the traditional approach. This came under criticism during the 1980s because people said that it's hard to get data on firms' costs a lot of the time. And so another approach you can take is by looking at two different demand curves, looking at shifts in demand curves that don't just change the level of demand, but change its slope. Because the extent to which the price is affected by the slope of demand determines the extent to which firms are sort of acting with market power, right? So to see that, imagine that initially we have this demand D2 here. And then we switch to this demand D3, right? Well, that's going to cause, in a competitive market, that's not going to change prices at all, right? But in a monopolistic market, that would cause firms to lower their prices by a lot because it's going to cause the marginal revenue curve to move by a bunch, right? And that, depending on whether the industry is acting pretty close to a monopolist or pretty close to competitive, could have a very small or a very large effect. So if we can find cases where the demand curve, rather than shifting, just rotates, we can use that to measure the extent to which the industry is working like a monopolist or like a competitive industry, and that'll measure the conjectural variations parameter. But conjectural variations can be used not just to summarize sort of explicit collusion, but just what you might think of as sort of natural strategic effects. So if when other firms increase their quantity, that's basically like this exogenous quantity increase that we talked about in the monopoly lecture, right? And that is going to lead me to want to increase the total amount supplied to the market by rho Q, right? That's what we talked about, the quantity pass-through, right? And this is going to require me to reduce the amount that I produce, or increase it, depending on whether this is greater than or equal to 0, greater than or less than 0, by 1 minus the quantity pass-through, which is the same as 1 minus the pass-through, right? So we can say that the other firm's quantity is a strategic substitute for my quantity. That is, when another firm increases their quantity, I want to reduce mine if the pass-through rate is less than 1. And it's a strategic complement if it's greater than 1. And when other firms change their prices, if another firm, say, reduces its price, that's going to shift the demand for my product, right? If they reduce their price, the demand for my product will increase, right? And that will lead me to move my price by 1 minus my pass-through rate, right? That's, again, what we talked about in that lecture. The sum of how much I move my price in response to a change in cost and a increase in demand is equal to 1. So price will be a strategic complement if the pass-through is less than 1, and a strategic substitute if the pass-through is greater than 1. So firms may, to some extent at least, anticipate that when they change their price or their quantity, other firms will just naturally have this strategic reaction. And that gets back to the model that, was it, Mike, were you the one in the beginning who was talking about the Stackelberg model? So almost every company, even if they don't think of themselves as colluding, is going to think, if I change my price, what is my competitor going to do? Partly just from strategic reasons, partly because he's trying to punish me. There's lots of different reasons why my competitor could react. And the nice thing about the conjectural variations thing is it takes into account both firms sort of trying to punish each other or being collusive, but also just taking their natural strategic reactions. And all of these are going to affect the degree of performance of a market. So let's consider the model that Mike was talking about. Just when firms take into account this sort of natural reaction, how is that going to affect what they're going to do in the market, right? So the simplest version is sort of a duopoly where one firm chooses its quantity, and then the other firm takes as given that quantity and chooses their quantity. So this is called Stackelberg Leadership. So the profits of the second firm, right, the one that is the follower, that just takes as given the first firm's quantity, are going to be the amount they produce times price, which depends on the two quantities, minus cost, which is the same as they're going to choose the total quantity minus the quantity produced by the other firm, times price, which depends on the total quantity, minus cost. Right? So this is exactly the same as that Q tilde we talked about from before, right? This is just, there's exogenously someone else producing this quantity Q1. And so we know that the amount that I will increase the total quantity when the Q1 increases by a little bit is equal to rho, right? Okay, so now the first firm needs to make its decision, right? It's going to choose how much of quantity to produce, given that the total quantity will be determined by the second firm according to this relationship here, that the total quantity increases in response to an increase in the initial quantity by the pass-through rate, right? And what, Matt, is going to be their optimal quantity in this case? Right, they're going to maximize their profits here, knowing that the rate at which the total quantity increases when they increase their quantity is the pass-through rate. You can come do it on the board if you want to. Or...
So, as they take the derivative, so
Yeah.
is so P in the times the pass-through
Yeah?
plus P prime times quantity.
Yeah. Q1 times P prime times the pass-through rate, right?
Right.
Plus